Hello everyone, we are going to introduce medical AI solution today, so please don't go away. Hello, this is David Hong from IEI Medical Computing Department. Today our topic is medical image AI lending solutions, and we have a special guest with us for this broadcasting today. Please introduce yourself first.
Hello everyone, I'm Adam from aetherAI. I'm the BD director of aetherAI.
Adam, would you please also brief the main business and core competence of aetherAI for our audience?
Yes, absolutely. aetherAI is a medical image AI company from Taiwan. We have a special focus on digital pathology system and the AI on top of that.
Wow, that sounds very cool. Okay. Artificial intelligence has become the hottest issue recently. However, as far as I know, because our topic today is medical image AI, so that is to say we will use it in the hospital. But as far as I know, for hospitals or medical industry, they would be more conservative for adopting any new application or service in their environments. So Adam, based on your experience, what would be the attitude or expectations for these medical professionals toward to the brand new AI application?
For the medical image AI, that will be very helpful in medical field, especially in medical image field. But right now, if they want to use this kind of application, we need to put the whole application seamlessly integrate with their daily workflow that can help their workflow daily.
Okay, and so given the points of the view from the previous slide, IEI and aetherAI roll out the medical image AI lending solutions together to meet the market demand. I think the keyword is seamlessly. Okay, and we know that the different departments of the hospital will have various AI applications. For easy management, IEI designed a smaller size box PC, and we have the product concept: one station for multiple service, and we try to make it much easier to implement the AI service to all kinds of workflow. So Adam, please share the concept of physician-centered scenario-based management to our audience.
Yes, inside of hospital, if you're trying to make a system to help the physician, or we say like the doctors, you have to let them can grab the images, grab the information from the system directly, very easily. But right now, most of the AI solutions that they build is on top of cloud.
Yes.
So for the hospital, they have security issues that cannot allow the informations or images go outside of the hospital environment. But for the server scale solutions that you put inside, like the on-premises cloud inside the hospital, they have the other problem about the bandwidth of the internet that may cause some kind of lag from the modality to the server inference. So in this solution, we are trying to put the server scale computing power, put it into the AI box that is so small, can put aside of their modalities to combine with their daily workflow.
Okay. As far as I know, in the past time, cell counting work is done manually. And this is not only a waste of manpower, but also a matter of efficiency or accuracy. So I think first of all, we would like to introduce a real case study. We are going to show how AI helped the medical personnel from the medical frontline in their daily routine. So definitely first we need to have a microscope and make it integrated with our AI box PC. And Adam, please proceed to introduce the configurations of the AI microscope.
Yes, we start with the microscope. Microscope is a traditional tool that's very helpful for the pathologist or hematologist that we mentioned here. So they use the microscope to look into the tissue or cells that they doing the cancer screening or counting different kind of bone marrow cells. For this AI microscope, we combine with the camera with the USB output and connect into the AI box that we put our pre-trained AI model inside of the AI box that can help them to do different kind of AI recognition for different hematology or the bone marrow cells.
Oh, recognize the bone marrow cells.
Yes.
That sounds very, very cool. But I'm also curious about what is the physical interface between microscope and our AI box PC.
Yes, this is may not the standard procedure or standard connection, but in this case, we use the industrial camera that's connect with the USB and to the AI box USB port directly. We use the camera SDK to connect the image with the real-time image.
Okay. So after setting up the hardware parts, here comes the key points, utilizing the AI model. So as far as I know, aetherAI has many state-of-the-art AI algorithms in the AI field. And as you can see in these slides, we are trying to let Adam to describe the whole product concept of differential counting of bone marrow smear.
Yes, as you can see on the left-hand side, this is the bone marrow smear images under the oil lens microscope. So this is a very high resolution images. So in regular or daily job, the physicians or the technician, they need to use the microscope to calculate the different bone marrow cells and put it into 10 different classes. And for one case, they may take 20 to 30 minutes to finish a case.
Okay. So I think if you guys are really interested about this AI microscope, please stay tuned. We will have a demonstration today later on. Okay, so after finishing the AI software parts, we will spend some time for the hardware parts. On screen, you can see our latest AI box PC, HTB-200 C236. Light but powerful is the core product concept. The small size makes it very easy to deploy in various medical environments. Equipped with the Intel Xeon processor, makes the delicate system having very efficient, powerful computing output. We will have two USB 2.0 ports in the front plates for easier data exchange, and LED lights indicates the system status. Most importantly, the smart fan design minimizes the noises made by the blower under different kinds of users' behaviors. In the back side, we will have power buttons, two USB 3.0 ports, a serial port, and a HDMI output for displaying the AI inferencing results. Besides, we also allocate dual LAN ports for the network management. As far as I know, the medical images will be centralized storage in PACS server in every hospitals. Adam, I know you're also very familiar with this field. Could you make a brief introduction of the medical image systems for our audience?
Yes, absolutely. PACS system is a medical image system that designed on top of the DICOM image, or we say the DICOM standard.
Yes.
DICOM standard is a special standard that designed for the communication between the modality to the server or the software part. So that's meaning they can, by a simple configuration, and send the image to the modality from modality to server directly.
Okay, if you guys still feel confused about, or you feel this is very abstract about the DICOM image transmission, don't worry, we will have a more detailed introduction in the following slides. I believe besides the bone marrow smear, the medical images are also widely applied in many other clinical scenarios, such as radiology, hematology, pathology, gastroenterology, and so on. We believe that there are more and more AI systems will be adopted in a variety of healthcare professionals. Due to the medical images files are normally too big to upload to the cloud, it is not only wasting of time, but also occupy too much bandwidth to finish the medical AI computing on cloud. Hence, an edge computing devices is really essential to offer AI landing solutions and also make it possible to greatly enhance the user's convenience. And HTB-200 is a perfect platform to work for this issue.
Yes, so throughout this collaboration, we are trying to provide the solution to hospitals or clinics or labs that like a small turnkey solutions that they can put the AI algorithm aside their working environment.
Yes, and I also believe that aetherAI could also help our customers in many other aspects. For example, if they want you guys to optimize their AI algorithm, or they want you guys to train AI for them, this is all project-based demand. You can fulfill it, definitely. Is that right?
Yes, absolutely.
Yes. And we also know that for cybersecurity plays a crucial role for AI developing company, because the AI algorithm is your precious assets of your company. So our Box PC enables the Intel Platform Trust technology. The software engineers can utilize the supported encryption protocol to bundle the software and hardware. And that is to say, if you just trying to steal it or you replace the hard drive to another one, it doesn't work. And these actions prevents the AI algorithms being stolen by the unknown third party. And I also know that aetherAI uses SD card encryption technology on this issue as well.
Yes, for this design, that is, we design as a secure SD for our AI model. For these solutions, we are trying to solve the problem that is we have to update different version of the AI model.
Yes.
So it should be easier if you have the new pre-trained model, you can just switch the SD card to get the new performance of the new AI model. And at the meantime, we can solve the other problem about we're trying to put different kind of AI models into a same design of the AI box. So if you put the AI microscopes algorithm into the AI box, it's become the AI microscope.
Yes.
If you put the endoscope's AI model, it's become AI endoscope.
Okay, so this feature also assures the mentioned feature, one stations for multiple purpose.
Yes.
After introducing the appearance of our whole systems, we are going to the inside of the whole systems. There are two PCIe slots reserved in HTB-200. A PCIe by 16 slot is ready for AI accelerators. And AI accelerators cards are crucial to the data scientists. So our systems have a very high compatibility for the GPU cards such as the NVIDIA P4, T4, or IEI Mustang series. And this makes the end users choose the AI accelerator cards based on their different kinds of needs. And we also have a redundant PCIe by 4 slots. This slot is designed for grabber cards or any other expansion purpose. We need to pay a special attention on NVIDIA Tesla for these cards. There are very limited Box PC in the current market available for these GPU cards. They cater to its passive heatsink designs. IEI adopts blower ventilation solutions. That is not only creates a strong airflow, but also minimize the noises made by the system fan.
Yes, so for this kind of design that we are trying to put a server scale computing power into a small box and put beside their working environment. So about the noise, about the security, that will be a major issue for the medical field.
Yes, and we also know that for the hospitals, safety is always a concern. So you cannot use the whole system, make the power consumption too much. If you consume too much energy, it is always a matter for the hospitals. Yeah, they need to care about the safeties of the patients. In the previous slide, we have talked about the DICOM transmission, so we will use this slide to have a further discussions on these issues. As mentioned, DICOM is the universal standard for medical images. The medical images generated by different kinds of medical devices. And it could roughly categorize into two groups, DICOM and non-DICOM. The commonly seen CT, MRI, or ultrasound are DICOM modalities, and their images are archived by lamp port. On the other hand, endoscopy or microscope are non-DICOM modalities. These images need to be integrated by grabber cards or in different kinds of I/O interfaces.
For this kind of non-DICOM modalities, we usually connect with the HDI or DVI input to the AI box with the capture card. So from the capture card, our system can capture the images and send it into AI model and output for the visualization results for users.
Yes, visualize is a key feature because it's the medical person they may not know how to train AI or how to integrate the AI, but if you can visualize the results, that will definitely to enhance their working efficiency. And I guess everyone must be very curious about how the AI inside the software, how the AI inference results from. So we asked Adam to talk about the AI workflow for you guys.
For the AI workflow, image coming from the DICOM or non-DICOM modalities and send it into AI box. The pre-trained model already installed into the AI box, and the pre-trained model can use the NVIDIA Tesla T4, like the GPU card, to accelerate the computing process. And later on, we can output by drawing the contour or the bounding box on the images and send it out. It can display on the monitor or also sent to the PAC systems by the DICOM format.
Okay, so I think the above is the introduction of the total solutions. So now we are going to show you guys a video. So then you will know that the whole process of the AI inference and the AI medical lending solutions.
For the AI microscope, this is designed for hematologists that have to calculate the bone marrow smear cells under the oil lens microscope. Traditionally, they have to read themselves, find the bone marrow cells and calculate it into 500 cells. But by AI, just one button, the AI will inference in 1.5 seconds and show the result into 10 different classes. Even the result is not quite fit for the final answer, user can use the interface to fix this result themselves. So after that, the 500 cells counts will send it into summaries that user can use in this scenario.
Lastly, we are going to share some of the information about the inference cards in the current market. AI Master V100 adopts 8 pieces of Intel Movidius VPU. The users can optimize the AI computing by Intel OpenVINO toolkits. The key feature of this card is its low energy consumptions. This will be a very cost-effective options for the end users. And on the other hand, if the end users need to execute more complicated graphical operations, NVIDIA Tesla ecosystem would be their first choices. NVIDIA Tesla 4 could have a very vast onboard CUDA cores, and its memory size will also help to accelerate the graphical computing. The above is the introductions of our medical image AI solutions. And as you can see in this slide, there are 2 QR codes shown on the screen for you guys to reach us. Please feel free to contact us for further information. We will be more than happy to answer any of your questions. Thanks for your listening today and see you next time. Bye-bye.
Bye-bye.